Vertex and roots. This lesson is all about finding the vertices and or roots of a given equation. I really only ask you to find the vertex on vertex form and standard form. And I only ask you to find the roots on roots form. So we're going to start here. This is what is known, as you all know, as vertex form. And it's far and away the easiest one that we can find the actual vertex for. So when I'm looking for the vertex, I'm going to say that. So classic vertex form is y equals a times the quantity x minus h squared plus k. You can see that this h and this k are different colors because when it comes down to it, if we're looking for the vertex is going to be, in parentheses of course, we're going to have negative h and normal positive k. So in that regard, I can look at this typical vertex form and I can apply what would h be, what would k be up here. And the answer would be h is going to be inside the parentheses. We're going to get 3. And my k is going to be negative 1. So here's something to think about. Right here it says that I have a negative h. That means that it's the opposite of whatever is in here. So if I have a positive 3, I'm going to end up with negative 3. It's not necessarily always negative. If my h right here was negative 2, it would be positive 2. It's just the opposite of what is inside the house. And then I'm going to get my comma, and k, on the other hand, is always outside the house after the square, and in this case it's negative 1, and that one's just going to stay negative 1. So there's my vertex. No math, just recognition. So far so good? Good. Next up we've got standard form, and I've already written right here the generic standard form. I've got y equals ax squared plus bx plus c. That is typical standard form. And notice that my a and my b are both in different colors. So maybe we're going to use those in our future equation. So let's get one. So here it is. And now once again, we're not going to do any math per se. We're going to just recognize that a is always attached to the x squared, and b is always attached to the x. So if a is always attached to the x squared, well, which one's attached to the x squared? I've got negative 2 that I made all sloppy. And likewise, what's attached to the x on my actual equation? I get 4. So now we're going to plug those into an equation, and that equation is negative b over 2a. So in this case, once again, negative b does not necessarily mean that it's always going to be negative. It just means it's the opposite of the number we're given right here. And that number we have is 4. So the opposite of 4 is going to be negative 4. Then we're going to go to our a. Our a is negative 2, so that's going to stay negative, but we're going to multiply it by 2. And then I'm going to put in negative 2. And once we figure this out, I get negative 4 over 2 times negative 2 is negative 4. And negative 4 divided by negative 4 is a 1. Hooray! What we just found is x. Obviously, our vertex is in x, y form. So what we just found is the x value of the vertex. Let me clean this up, and now we're going to take this number, which in this case happens to be 1, and we're going to plug it in to this original equation, and that's going to give us our y. So now we're going to take our new answer, x equals 1, and I'm going to plug in 1 anywhere there's an x, just like when we're filling out a table. I want to make sure that each and every x here, we're going to take that and replace it with 1. So let's do that. I get -2 times 1, and that one's going to be squared. I put the squared inside the parentheses only to remind me that I go 1 squared times -2, not -2 times 1 squared. That'll give us a different answer. Plus 4 times 1. This one we don't have to square. And then minus 3. I end up with 1 squared is going to give me 1 times -2 is going to be -2 still. 4 times 1 is 4, so I still have a plus 4. And then -3 doesn't change at all. And now -2 plus 4 is positive 2, minus 3 is -1. So now I found my y value. And my final answer is 1, -1. Finally, we're looking for roots. This is obviously root form. And once again, I'm sure you notice the P, the Q, they're different colors, so we're definitely going to be utilizing them. So let's get an equation. All right, so I have this equation. And once again, I just need to recognize that P and Q are elements of this equation. So in this case, my P is going to be right here, 2. And my Q is going to be -3. Again, we didn't actually do any math. We're just recognizing that I can look at this generic equation and then I can apply what I know about it to this one. So now, once again, we know that -P, -Q does not necessarily mean that your answers are always negative. It means that it's the opposite. So what I'm looking for is roots are always whoopsie-daisy. I got -P, comma 0. And I've got -Q, comma 0. Again, not necessarily always negative. So for this case, I have a +2 as my -P, so I have to flip it. I'm going to say it's -2. And then likewise, I always get a 0, sorry. And then for the next one, I have -3, but I need to flip it, so it's going to be +3. So it's just the opposite of what the equation says, because math is supposed to be confusing, right? But that's it. I took my P, I took my Q, I flipped the signs, and now I get this answer right here. And those are my roots. That means that the parabola actually breaks through the x-intercept at these points. Thanks for watching.